shop here today, and we're going to start cutting up the parts of these two flat panel doors for this customer. And I've got a nice piece of red quarter sawn oak and quarter sawn red oak, whatever you want to call it. And it'll actually work out really nice because I'm actually staining and finishing these as well. And the stain color I had, which was a match to this particular color before for somebody else, was a little bit light and missing a little bit red. And when I tested, I just tested on regular red oak, which wasn't quite as red. So this will definitely help me out, and hopefully I won't have to tweak the stain anymore. So yeah, so I'm just going to slice out a couple rips here to the appropriate width. Then I'll take them over to the chop saw, and I will cut the parts out, and then we'll machine it. All right. And as long as I'm at the saw here, I'll also take the time to cut out the 1/4 inch two-sided center panel. The center panel will be also quarter sawn red oak, quarter sawn on one side, and flat sawn on the other, which will be the back side. And I will cut that tight to fit, basically about a 32nd of an inch less than the door. And I probably will glue the panel in place, being it's an MDF panel. I'm not sure yet. Normally I use Spaceballs for this, but depending on how loose that panel is, I might want to glue it instead. Now that I have the quarter sawn red oak ripped to width, I'm going to take it over here to the power miter saw, and I'm going to cut out the stiles first, and then I'm going to rough cut the rails. And the reason I'm going to rough cut the rails is basically the rails are going to finish at 4 inches long, and the power feed won't handle 4-inch long stock, especially with an open face fence. So basically I'm going to make those rails longer out of some short cutoffs, and I'm going to tenon one end, and then run the stick, and then take it back to the power miter saw here and cut it to the correct length, plus a 32nd, and then I will machine the remaining rail. I'm going to cope one end of all the rails, and then I'm going to remove the coping jig, move the power feed into place, slide in the auxiliary fence, set the depth or the width, and then run all the stiles and the rails. So now that I have the ends coped, I'm going to move the power feed into place and slide in the auxiliary fence and set the width for 2 13/16. Now the stiles and rails in this door need to finish at 2 3/4, and the reason I'm going 2 13/16 is because I build every door in the shop here 1/8 inch oversize. One might argue I don't need to do that, but the reason I do that is because number one is the stiles on this particular door need to finish at 2 3/4 to match the existing doors. And number two is when I build it oversize, it allows me to set my outside profile up to remove a 1/16 of an inch all the way around, to remove the saw kerfs and put the outside profile on. And it's very easy to sand the outside profile versus saw kerfs. Even if you got a really good saw blade, the profile takes a very minimal sanding compared to a table sawed edge. Now that I have the power feed set up along with the auxiliary fence, there is no height adjustment to the spindle set. It's basically plug and play. That's why I've taken the time earlier to shim the cutter set so that way the tenon and the sticking line up perfectly on the face. Any variation will be on the back because I run face down. When I run the rails, I have to run them a specific way. I want to run them so that way the tongue is on the leading edge. Now the cutters I use here are run face down in a counterclockwise configuration. If you might be asking, the spindle speed is 7,000 and the power feed speed is 26 feet per minute. now that I have the sticking cut in all the pieces, I need to take those 4 rails back to the power miter saw and cut them to their final length, plus a 32nd of an inch. Now you might be asking, why are you cutting them a 32nd of an inch long? Well, basically here's another trick that I do as well. I run my rails a 1/16 longer than normal, and when I cope the ends, I take off a 32nd on each end. So to allow for a 4-inch finished rail, I have to cut them 4 and 1/32. So when I cope the remaining end, I don't have a short rail. Now you can see why it's very important if you do something like this here, if you run a longer piece and cope one end. This is the reason I had to set the coping jig back up here to cope the remaining end. And now you know why I specified earlier that when you run these through, that you want to run it through with the leading edge first. Because now I have the square edge against the blowout block and the coping jig, and I have the profile in the front, so it won't blow out the nice profile. Some of you might ask as far as why do I use an air sander versus an electric sander. Basically, I prefer an air sander over an electric sander, typically like your typical Porter Cable, DeWalt's, Makitas, Ryobi's, ones like that. That's how I very first started, and up until probably about 10 years ago, maybe 9, 10, somewhere around there, I had acquired an air orbital sander basically as a demo unit for when I was buying my sandpaper, and so just give it a shot. At the time I had a Canva Housefield single stage air compressor, 60 gallon, and it was everything it could do just to keep up with that, to keep up with the demand, and really it got to the point where it just couldn't keep up. If you have one of these air orbital sanders, what I will tell you, a 60 gallon single stage won't cut it. It'll work for a while, but it won't maintain what you need to do. Ideally, minimum of a 5 horsepower 2-stage compressor that puts out at least, say, 17 CFMs. Some of the 5-horse compressors out there actually put out less, some around like 16.9, some are 16.5. There's some that are as high as 19.1, all rated at 175 PSI. If I was to buy another new compressor and I had the power and the money, I'd go to a 7.5 horse, probably buy a cast air or a Sailor Beal. If you really will have the money, or if you can find a good used one, the Quincy QR25 series model 325 is an excellent workhorse. I actually still have my 325 pump, it's just that I took it out of service for a time being because the tank had sprung a leak. And I just decided that maybe I should buy another new compressor, and eventually what I'm going to do is get another tank for the old 325, put the two in, plumb them together, and use an alternating relay so each compressor takes turns. So that's plans for the future. But anyways, yeah, an air orbital sander, they're very, very nice to have. They give you a very nice clean finish. Basically they're almost swirl free, or they are swirl free, providing that the pad on the bottom isn't tore up and that you don't have any debris on the pad, whether it's leftover adhesive from a sanding disc or a torn disc or whichever. The pad's got to be clean, because if it's not clean, you're going to have swirl marks, and you might not see it on a light color, but you'll definitely see it on a darker color. And the nice thing too is you can get different orbit sizes in a orbital sander. Basically, when you purchase one, or if you order one from a distributor, you can specify as far as what orbit you want, as far as the orbit rotation. Typically they're 3/32, 3/16, and 3/8. 3/16 is pretty common. You run the risk of a couple of swirls if your pad's not in perfect condition, or depending on your abrasive. And then the 3/32 is really ideal. and the 3/32 is probably easier to control. But you know, 3/16, 3/32 are both pretty common here in the wood industry, so that's kind of another nice advantage of it. I may actually use this for the side, for the outside compared to this. This actually has some nice flecking in it, but the one I saw was on this side here. I kind of had a seam that I wasn't really crazy about. It's got a real wide grain as well, which almost makes it look like it could have been young growth red oak to use this. The color is not bad, but compared to the frame's a little bit more red, which actually I will benefit from when it comes to the finishing process. But looking at this here, this is actually a little bit better. It may be just a little bit darker, but really the overall color looks better than this side here. This actually looks to me like it could be quarter sawn as well. It's got a real tight grain, which is my biggest concern. So I know normally when I order this in the shop here that when we do quarter sawn, it's typically a quarter sawn one side and flat sawn the other, but this actually looks to be quarter sawn, so that'll work out better. Like I said, I love the grain pattern on this side. It's got some nice flecking in it, but unfortunately the color is just not right. And the one thing that I just don't like is a two-tone door. So I'm going to use this side instead of this side. So these are going to be ready to go. So in the next part of this video series, we're going to actually put these doors together, and then we're going to machine the outside profile, sand them up, and then also drill for the hinges. The hinges are a concealed hinge. They're actually a Bloom 39, I think it's a 39C. Anyways, it's a Bloom concealed hinge, 1.25" overlay. So these doors, like I said, will finish at 8.5 by 29.5, and the opening is only 6 by 27, I believe. So yeah, that will be on the next part of this video series. Alright, questions and positive comments are welcome. Thanks for watching.